3.
All right, so our first assignment here in construction manufacturing is going to be making a paper box that has some tolerance in it. The box is to slide in and out here and be even length. This is an isometric drawing, which we'll be learning in the class. This is a 3D orthographic drawing, which shows the front, top, and side views. These are the places where we put dimensions on. This is the place that becomes more understandable. So this is what we're work off of, but we're actually working off of our plans, these plans right here. These plans date back to the early part of the previous century, where Sloyd was talking about training students' hands and so forth. And very honestly, when I read some of this Sloyd stuff, it seems like it's lofty for the age that it was intended for at the time. It suits older kids better nowadays. This is a 9th grade class that I have in here, and we're going to make the box. It has two sides. It has the box portion of it, and it has the case portion of it. This part here. When you read the instructions, they really strike you as being old language, where it says, construct an oblong 5/8 of an inch, 3 5/8 of an inch by 9 1/4 of an inch. Place dots at the top and bottom, blah, blah, blah. So I want to go through the process with you. We're using poster board to do this with, and show you how we're going to be laying this out, how we're going to make sure that things are square, and so forth. Okay? So let's go over to the table over here. Remember in here, as we're getting ready to work with materials, you guys need to, as you walk in, clean your hands, and it's been a while since then. You need to use the sanitizer gel. Get both your hands done before you start using the community materials. We're going to be working with poster board to make this. And the overall size, I'll do this is the box case portion first. This is down below here. It says construct an oblong 6 7/8 by 7 1/2. Okay? So that's where we're going to start. Clean hands, I'll go ahead and grab one of my framing squares. And I'm going to set the framing square up to one of the corners of a factory sheet. Okay, so I know there's a 90-degree angle on this factory sheet here because when the manufacturer sends it to you, we're insured 90-degree angles. So I'm going to work with this to come up with my overall size. I need 6 7/8 by 7 1/2. Okay, let me grab my pencil. And I will go 6 7/8 by 7 1/2. So I have two marks here, correct? Now I'll take the square and I'll go to 6 7/8 right here. And line that up with where the edge of my paper and my 7 1/2 dot is. 6 7/8 by 7 1/2. So we see those two locations here. Now I'm just going to bring those together, and that's going to give me the size that I need here. This is not as big as what the oblong is going to be on the other side here, but the reality is I would not cut this with a pair of scissors. Even in 9th grade, a lot of the scissor use that we have here, the scissor ability that we have in 9th grade is not that great. So instead we're going to use table shears. Now table shears is more accustomed to cutting sheet stock in it, sheet metal, but it'll certainly cut poster board without a problem. So I'm going to walk over there and make that cut. If I had never labeled my 6 7/8 and 7 1/2, I could still make these cuts. Put it on here. I'll bring my line to the edge of the table. Come on here, let me show you where the edge of the table is. So you can see the back edge of the table there, and you can see that where I'm bringing my line up to it. Right here is where I want you to be looking at, right at that location. So my line comes up to it, and I bring it over to this guide here, this metal guide that has the scale on it. And I'm setting that to 6 7/8, which lines up perfectly with where we're at. If it's against my scale, against that guide, then it'll be a perfect 90-degree angle. I'm going to hold the back side of my paper with my other hand. I'm going to cut through. A stepping motion that I'm cutting through with. So the blade moves with my step. So now I have a piece that's left over that I can set on the table here, that I can guarantee to the next person is going to be a square piece of material that they can use for for their project. Now 6 7/8 by 7.5. This is 7.5. I'm going to lay this in here again, and I'm going to bring it down till the end of my paper. Back here is at 7.5 inches according to the scale. Right there looks good. And if you notice, my pencil line is right on the edge of the table. I'm going to go ahead and I'm going to step through. My hands are not in this area. Here's my blade right here. My hands are not in the area. Now I've cut the board to that size. Now I did oil this table up this summer, so there is going to be a little bit of oil on there. I'll wipe that down again to make sure that that's cleaner. But when we're using this machine, a couple things we need to be concerned about. When you step on this, you got to make sure that your leg is not up against it. Your shin is going to be straight as this thing goes down. So you have one hand on the table, and one hand steps down, bringing the blade down, bypassing the back side of the table. When you hold the pieces coming out the back there, you need to be able to see your hand. The only way you can get hurt on this is, one, you're just skinning your knee, but back here, if you try to grab something that's too small, that you're actually reaching your hand over the back edge of the table back here, in this area, then there's the risk of cutting your finger. That would really, you really have to be in a precarious location to be able to do that. So I don't imagine that happening. Okay? So here's the piece for our case. Let's go back over to the table. Power outlet. It looks like the phone is dying that we're doing this videoing on, so I want to make sure we don't lose it entirely. And so let's look at the plans. The plans say, construct an oblong, 6 7/8 by 7.5. Place dots on the left and the right at 7/8 of an inch. So up here is where 7/8 of an inch is. That's the space that this first dotted line is from the edge. 7/8, then 2 7/8. So that's 7/8 and that's 2. So if we came to the next line, it would be 2 plus the 7/8, so it's 2 7/8. Then 3 7/8. 1, 2 7/8. The next line is 3 7/8. So they're working down from that top there. Okay, so you're starting at this end. Okay, we're putting dots on the other side and drawing them across. What becomes really important is that your lines are parallel, because if you have a side to the box here, where one side's wider than the other, that's going to hinder the ability of this drawer to be able to bypass through here. So we want to make sure that we have them nice and parallel and bring in them. So, a couple ways to do this. We could take a ruler, and as they're saying here, and the other thing is that this is 6 7/8 by 7.5. That kind of looks like a square, right? We just want to make sure that we're setting it up right, so that the 6 7/8 and the 7.5 are oriented on our table the way they're oriented on the page here, so that we get this correct. So this is my 7.5 here, so I have it oriented correctly. 7.5, that's 7.5. So they wanted to come down 7/8. So I can go ahead and I can bring my ruler right to the edge there and mark it at 7/8. So what is this project doing? It's backing up what we just spent our first class period talking about, which is measurements. So now I want to see, you've learned the measurements, now come back and we're going to do them on this paper here. We'll make sure we get this right. So we have 7/8, and then the next one would be 2 7/8. So 1, 2 7/8. And one thing you want to make certain of is that you don't allow the paper to shift in between. So if it does shift, just make sure your 7/8 one is right along the 7/8, and 3 7/8, or 2 7/8, and then 3 7/8, and then 5 7/8. 1, 2, 3, 4, 5 7/8. Okay, so our two ends here. Our top one is 7/8, and our bottom one is 1 inch. Number 2, 1, 2. So I just want to make sure that it did work out to be 1 inch. It looks good for that. So now I'm going to work from the other side. Do the same exact thing. Where I'm going to go 7/8, 2 7/8, 3 7/8, and 5 7/8. Right? Now I want to use this to draw those lines across. So I'm going to line them up to my points here. Draw that line across. That line. And then when I do that, I want to take a look at it and just make sure that it looks right. So it looks pretty good. This side looks a little bit wider than that. I'm not sure why. That's 1 inch. That's like a hair under 1 inch. So I want to go back and just check this again, make sure that I feel comfortable with this. And that's just a visual test there. So 7/8, 2 and 7/8, 7/8, 2 and 7/8. Could have been over here a little bit more. 7/8, 5 and 7/8, and that looks pretty decent. Okay, so I'm going to live with that. Next thing is that we want to be able to bend these. We want to be able to bend nice, tight bends so they don't loop. If I tried to bend this line here, I would have a pretty difficult time. I'd probably bring it up like this, bring it over the edge, and then bend it against this ruler, and run the risk of the ruler kind of shifting as I'm trying to bend it. Rather than doing it that way, we're going to take what's called a scratch hole of our tool cabinet. Now, a scratch hole is nothing more than a piece of steel that has a point on it. Usually some tools to it gives it a little bit more durability. But I am going to use this to run down that line. So it's going to be like this. I want to make sure that my point comes down on it. It goes right in that line. And I just follow that line through. And I come to this one. So what I'm doing is I'm giving a real indentation to this line here. And that line indentation is going to convince my paper to bend right where the indentation is. So if I bend these now, you can see what a nice crisp edge, a 90-degree angle I get with that bend. Fold and paste the 7/8 inch lap inside. So we said there was a 1 inch side and a 7/8 inch side. Got to make sure you follow that instruction that it's folded on the inside. Okay? Next video I'll show you how we're going to attach it.